Hello. The footage you're about to see is provided for illustration purposes only and remains the property of WDC company. They sent them for allowing us to showcase their quarry in action. Welcome to our webinar, Soft Rock Stone Waste from Quarries as a raw material for Hyperpress technology. Today we'll explore how what we once called waste can become the core ingredient for ultra green bricks, blocks and tiles. Let's start deep in geological time. For hundreds of millions years, vast seas covered the areas that are now our limestone and dolomite quarries. When marine organisms, corals, mollusks, plankton died, their calcium-rich shells drifted to the seafloor. Layer upon layer, those shells compacted, squeezing out water, locking calcium carbonate and magnesium carbonate into solid rock, and permanently binding the CO2 they once drew from the atmosphere. These sedimentary carbonates, limestone, dolomite, travertine, chalk, and shell-rich coquina, make up close to 20% of Earth's crust. They are plentiful, fairly soft to extract, and crucially already carry the chemical backbone our hyperpress bricks need. In other words, the carbon is already captured, we just have to shape it. Okay, so let me start video. And now we're gonna see how a modern soft rock quarry works. First, everything starts from geological survey and planning. Geologists map every bench, logging chemistry and hardness so the quarry can target the cleanest carbonate horizons. Next step is related to overburden removal. Bulldozers strip away the thin layer of soil and vegetation, stockpiling it for later land rehabilitation. Next, we are drilling and using controlled blasting. Shallow boreholes and low energy charges fragment the rock while minimizing ultrafine sand vibration. Next step is related to excavation and haulage. When wheel loaders or front shovels load 60-ton haul trucks that crawl to the primary crushing station. Okay. Primary crushing mostly related in most cases it is related to jaw crusher. A rugged jaw crusher snaps 800 mm boulders into first sized 150 mm pieces. Then we proceed to secondary and tertiary crushing. When impact or cone crushers continue the work, achieving the cubical grain prized for construction aggregates. In the final stage, we use classification, screens and sieves. Multi-deck vibration screens sort the flow into commercial fractions from 20 to 40 millimeters, from 5 to 20 millimeters, and the finest stream, usually from 0 to 3 millimeters, or from 0 to 2 millimeters, or from 0 to 5 millimeters, depending on mesh size. Those dusty fines are called stone sievings. And now we will see this fraction a little bit later. Let's wait a bit. Okay. I think I'd better rewind. Okay, yeah. I think it is the most important part of our video, so I wanted to emphasize your attention to it. Once again, here's the catch. Customers rarely pay for the fines. They pile up in vast mountains, millions of tons per quarry, billions of tons worldwide, awaiting costly disposal or reclamation. For us, that's not waste, that's opportunity. Okay, and now you can see these stone sievings, or like from 0 to 3 or from 0 to 5 millimeters. It is what we need exactly, just to avoid confusion. There is no need in commercially sellable 0 to 40 or 0 to 20 millimeters. We need this waste. Once again, okay, just to double check on this and to remember how it looks. Okay, good. Let's proceed further. Why stone sievings are perfect for hyperpress? Hyperpress technology forms bricks through shear compaction. No firing, no autoclave. To succeed, we need two things: a microgranular carbonate skeleton for density and a modest dose of binder, usually 8-10% ordinary Portland cement or low carbon geopolymer. The Quarry's 0 to 3 mm sievings already possesses the right mineralogy, humidity and surface area. We reclaim them straight from this greenhouse, maybe mill them a little finer and feed them, still cool, still through neutral, into a high shear mixer. Inside the TITAN Hyperpress, hydraulic rams squeeze the mix at up to 30 megapascals. In 10 seconds, a dense green brick pops up. It cures overnight in a warm, humid chamber. No 1000 degrees kiln, no fossil fuel flame. Compared with fired clay production, we cut energy use and associated CO2 emissions by up to 70%. Better still, the carbonate bricks slowly reabsorb a little atmospheric CO2 during their lifespan, tipping the balance even further toward net zero construction. Repurposing soft rock quarry waste answers three crises at once. It shrinks waste dumps, slashes embodied carbon, and delivers affordable housing materials. This isn't a distant dream. It's running right now in Europe, Asia, Africa, and the Americas. So, whether you operate a quarry, design sustainable buildings, or campaign for climate action, consider Hyperpress technology your ally. Turn finds into fortune and build the greener world we all need. Thank you for watching.